Okay, am I recording? Yep. Okay. Okay, the next one is very, very similar. 172. Integration. Root 1 plus 2/3 x power minus a third squared dx from 1 to 8. That is 1 to 8 root 1 plus 4 over 9 x power minus 2/3 dx. That is 1 to 8, 9 over 9. I can take the 3 out, that's a third. And that's 9 plus 4 x power minus 2/3 half the x. Okay, let's try and get this to be a better form. So I'll put a 9 here, and sorry, a 4 here, and a 1 over 4 here, and then a 3 over 2 here, and a 2 over 3 here. No, that's not going to work. In fact, I'm not sure. I might need a substitution now. But I will take the 9 out as 1 over 3. So let's try the substitution. U equals 9 plus 4 x power minus 2/3. So that means du dx equals 9 minus 8/3. Bring down the power, reduce the power by 1. No. It's equal to 1/3, 1 to 8, root 9 plus 4 over cube root x squared dx. Now it did say in the book that if you cannot evaluate the integral exactly, use technology to approximate it. So let's just see what happens here. Square, oh, yeah. Fx is x power 2/3. So we'll differentiate that. And then we'll say square root 1 plus 9/4 squared. And then we'll integrate that from 1 to 8. Let's see. Okay, so it actually does come out in third form. So there must be a way. There must be a way to integrate this using some kind of substitution. So let's really put our thinking caps on, and we'll definitely need to make some space here. Right. It's going to be a tough one, I think. So the power is a problem. Power is a problem. Let's see. If you had something like 1 plus x power minus 2/3 power 3 over 2, and you differentiate that, that'd be 3 over 2, 1 plus x power minus 2 over 3, a half, and then the power would be minus 2/3 x power minus 5 over 3. There's no x on the outside, so I don't think it's going to be a nice substitution. What about... what would happen if we use the substitution u equals x root 9 plus 4x power minus 2/3. So the x there will be the root part, which we have, 9 plus 4x power minus 2/3, and then plus x, and then bring down the power, reduce the power by 1, and then multiply by the inside derivative, which would be minus 2/3 x, and then reduce the power by 1 minus 5/3. But then we can multiply by x to bring it back to minus 2/3. And then maybe is that better or is that worse? Hmm. 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 What if we were to use another substitution? The halves cancel. What if we were to say b equals x over root 9 plus 4x power minus 2/3. So the derivative of the v1, it's 1 over that root. No, that's not it. These variables being the same is nice, but how can I exploit that? That's not the right substitution. Oh, let me pause and think. Okay. Okay, let's look at this. 1/3, 1 power 8. The square. Maybe we should try and get rid of the negative power. So, oh, okay. I don't want the negative. Okay, let's deal with the negative. X plus 4 over x power 2/3 half the x. Okay, so that's 1/3, 1 to 8, 9 x power 2/3 minus 4 over x power 2/3 a half dx. I can get rid of the negative power. So that's 1/3, 1 to 8, 9x power 2/3 minus 4 1/2 over x power 1/3 dx. Oh, this is looking promising now. 1/3, 1 to 8, x power minus 1/3, 9, 2/3 minus 4, x power 1/2 dx. 1/3, 1 to 8, x power minus 1/3. So bring down the power. Okay. Reduce the power by 1. Okay. I need to make this look like a derivative. The power. No. Third, 2/3, 2/3, 3/2, 9, 9, 9x 2/3 minus 4 1/2 dx. So cancel. 1/27. Okay, now let's see if this works. So that now maybe is the derivative of this. So bring down the power. Let's check this off. Bring down the power. Oops, I forgot that part. Did I? Oh no, sorry. 3, 2. Okay, bring down the power. Reduce the power by 1. And then multiply by the inside derivative, which is 9. And then bring down the power, 2/3. And then reduce the power by 1. So this whole thing here is the derivative of that. So it should be 1/27, 9x power 2/3 minus 4 power 3/2, 1 and 8. So if I put in the 8 first, that's 1/27, 9, and then 8 squared is 64. So it's the cube root of 64. It's 8 power 2/3. So that's just 4. So 9 times 4 is 36 minus 4. And then minus, and I put in 1, which is 5. Oh, and I forgot there's a 3/2 and a 3/2 here. So that'll be 127, 32 power 3/2. It's kind of not nice. 5 power 3/2. Again, let me check the answer and derive. Yeah, it was 80 root 10/27. So minus 13 root 3/27. 80 root 10. I make a mistake here at the end. Hang on. Okay, 9 times 8 power 2/3 minus 4. That's 32. Power 3 over 2. It's 181 though. Close. Must have made some small mistakes somewhere. 2's cancel. 3's cancel. That's 27. 6.7. And then if you put the 1 in, that's 5 power 3 over 2. That's also a decimal. But well, wasn't it? Something went wrong. Squared. So that's 4, 9, minus 2 over 3, 9 over 9. Take the 9 out as a 3, like that. And then change that to positive power. And then change that to 9x2 over 3. Huh? How did that become minus all of a sudden? Ah, maybe that's the problem. All right, see if that fixes it. 9 times 8 power 2 over 3 plus 4. Aha, 40. So that will equal 1 over 27 and then 40. 40. It's 40, root 40 cubed. So I could change 40 into 4 times 10 cubed. So that is 64 times 10 cubed. Oh, that would be 80 root 10? 80 root 10. Ooh, nice. 80 root 10 minus, and then if I put the 1 in, 9 plus 4 is 13 power 3 over 2. I don't really think there's much to do with that. 13 power 3 over 2. So that'd be 13 root 13. Oh, nice. So finally, we get 80 root 10 minus 13 root 13 over 27.